Hi everyone, welcome back to the channel. It's great to have you here again. In our previous video, we discussed what SSH is and how to connect to an EC2 instance using its public IP. Now that we are connected to a Linux server through SSH, let's start with some fundamentals. In today's demo, we will explore the Linux folder structure, which is mostly common across all Linux distributions. Whether you are using Ubuntu, Amazon Linux, CentOS or Red Hat. Understanding this structure is the foundation for every DevOps engineer because it helps you know where configurations, logs and installed tools actually live. So, let's jump into our EC2 terminal and get started. I have created an EC2 instance for this demo and this is the public IP of my instance. I have connected to it from my terminal using SSH and now I am inside a Linux environment running on my EC2 instance. Let's start exploring some basic Linux commands and understand the folder structure, which is mostly common across all Linux distributions. Let me clear the screen. I will type pwd. So pwd shows our present working directory /home/ubuntu. Who am I? And who am I tells us which user we are logged in as. Here it's the Ubuntu user. By default, the Ubuntu user's home directory is /home/ubuntu. Let's check ID. Every user in Linux has a unique numeric ID. UID means user ID. For example, UID equal to 1000 means the system assigned 1000 to the Ubuntu user. The root user always has UID as 0 and GID means group ID. Each user also belongs to a primary group. Here GID equal to 1000 Ubuntu means the primary group's name is also Ubuntu. Groups. This lists all the other groups the user is part of. For example, ADM, admin group, can view system logs. Sudo can run commands as administrator. CD-ROM can access CD or DVD devices. So this tells you exactly what permissions and access your user has across the system. So ID gives you a quick summary of who you are in the system, which group you belong to, and what level of access you have. Now that we know our identity, let's move to the top of the Linux directory structure, the root directory. We can move to the root directory using cd/ and ls-l. When we run ls-l, we get a detailed list of all directories. That first character tells us what kind of entry it is. D means it's a directory. L means it's a symbolic link, kind of like an alias or shortcut pointing to another file or folder. So for example, here the /bin starts with an L, meaning it's a symbolic link pointing to /usr/bin. Let's check that. and here dash or hyphen means it's just a regular file. Let's go back again. So that's all the first character does. It tells you whether you are looking at a folder, a link or a normal file. Now let's explore some other directories here. Let's go to home, cd home, ls-l, and the /home directory holds all user folders. For the Ubuntu user, the home directory is /home/Ubuntu. We can also check it using home environment variable. Let's try that. So this tells us that the Ubuntu user's home directory is /home/Ubuntu. In Linux, this $home is an environment variable, a special kind of variable that stores useful system information. Every user on the system has their own home value. For example, if you switch to the root user, this $home would become /root. And these environment variables make automation easier because scripts, Ansible playbooks or Jenkins jobs can just refer to home instead of hard coding full paths. And we can check all other environment variables using printenv or env command. Let's try that. Let me clear the screen. Printenv. You will see many others here, like user for the username and path for executable search paths and shell for your default shell. We will look at this path variable next because it explains how Linux finds commands like git or python from anywhere. Now sometimes you will need to perform administrative tasks that require full system privileges. For example, installing software or changing protected files. For that, we can switch to the user root, which is the super user in Linux. Alright, let's go back and explore some other directories. We will go to this /usr/bin. Let me clear the screen, and ls-l. So this /usr/bin holds most of the commands and tools we use every day. Let's quickly verify that here. We will come from the top. We can see apt, bash, chmod, chown, curl, and many more here. Git, and we can also verify see here Python 3 and so on. And you can confirm their paths using which command? They all point to /usr/bin. So now we have seen that this /usr/bin holds all the main executables like git, curl and Python 3. But how does Linux know where to find these when we type their names from anywhere? That's where the path variable comes in. Let's check it. Let me clear the screen again and we will try echo $path. If you see the output, when you run this, you will see a list of directories separated by colons. Each of these directories contains executable files, means the actual commands. So when you type git, the system checks each directory listed in this path variable one by one until it finds a matching executable file named git. Let's try that. Which git? See the output. For git, we see /usr/bin/git. And which Python 3? /usr/bin/python 3. Both git and Python 3 are stored inside this /usr/bin. And since this /usr/bin is already part of this path, their executables are added to one of the directories inside this path variable. So Linux can find and run these commands from anywhere in the system. You don't need to type the full path. As a DevOps engineer, this is really useful to know because when you install tools like Docker, Ansible or Terraform, their executables are added to one of the directories inside this path. That's what makes them available globally on your terminal. So now we understand both home, which points to our user's home folder, and path, which tells Linux where to find commands. Next, let's explore some of the important directories that form the Linux file system. Let's go back again. Let me clear the screen. Let's explore /etc. So this /etc is where all your system configurations live. So the /etc stores system and application configuration files, and you will find, let's explore, see SSH. The SSH configurations in /etc/ssh, and we can also see the system details like the host name. Let me clear the screen. We'll go back to the root again. And let's explore lib/usr/lib. This /usr/lib contains internal libraries and dependencies used by the executables in /usr/bin. For example, OpenSSH. It supports SSH commands, and Python 3 contains Python's standard modules. So usr/bin is like the front end, and this /usr/lib is the back end. Let me clear the screen and let's go back again. Let's check this var cd and let's explore this log directory. So logs live inside this /var/log. For example, system log, syslog, and auth log. This is where you look when debugging issues occur. Let's go back again. And this /temp is for temporary files, and this gets cleared after reboot. And this /opt, this is where we manually install extra software like Jenkins or Tomcat. Right now we don't have anything, and let me clear the screen and let's quickly go back to the root again. And we have other directories like sbin for system admin commands, and boot for kernel and startup files, and lib for shared libraries we already verified, and this /mount and media for mounted drives, and root, which is the home directory for the root user. So you won't touch these every day, but it's good to know they exist. Now that we understand the folder structure, let's install a software package, Ansible, and see how these folders are used internally. Before that, let me go back to the /usr/bin. Let me clear the screen. Right now, if you observe, we don't have Ansible present. And let's install Ansible and come back here and verify the installation. Let's try that. Let me clear the screen. And so we will use two commands here. Sudo sudo, which gives us admin privileges, and apt, the package manager that handles installation. So sudo stands for super user do, and apt manages downloading and installing packages from online repositories. This sudo apt update, we start with this command, and this refreshes our package list from the repository sources, so we get the latest versions. Let's try that. And let's install Ansible. For that, the command is sudo apt install Ansible, and give y and continue. And now we will install Ansible, and during installation the main executables go to /usr/bin, and Ansible's internal modules are stored inside /usr/lib and Python distribution packages. We can verify that after the installation process. It's almost done. See, it's setting up Python 3. And it's completed. Let me clear the screen. Let's verify installation. We can do which Ansible. See, /usr/bin/Ansible. And let's verify the version. It's Ansible core 2.16.3, and it internally uses Python. We can see the Python version here too, and it's available in /usr/bin Python 3. So which Ansible confirms it's installed under /usr/bin, and Ansible version shows the installed version. And we can see all multiple Ansible command executables inside /usr/bin. Let's explore that. Let me clear the screen first. Let's go back to the top. See, Ansible, Ansible community, Ansible config, Ansible connection, Ansible console, Ansible galaxy, Ansible playbook, everything. So all the multiple Ansible command executables located inside this /usr/bin. Let's explore internals. Let me clear the screen. We will go to the distribution packages. Let me go to the Python 3. Okay, we need to go to the library first. Let's go to the root and come back from there. Then it would be clear. So we should go to this usr/lib. So cd/usr/lib, and let me clear the screen and do ls-l. And now we have here Python 3. Let's go inside that. So cd Python 3 and do ls-l. We see the distribution packages. Let's check. we can see Ansible here. So here's where Ansible's internal logic lives. You can see collections, and so on. Let me clear the screen and let's go to Ansible. We can see modules, playbook, plugins, collections, and all the core components here. Let's uninstall and verify. For that, we use the command sudo apt remove. Let me go back to the root. We can perform this operation from anywhere. It will apply that under /usr/bin. Let's try that. Sudo apt remove, and we would like to remove Ansible. So Ansible. Give y to continue. So this will uninstalls the package. Let's check. We still see Ansible exists here. So to clear the leftover dependencies, there is another command called auto remove. Let's try that. Let me clear the screen again. So sudo apt auto remove, and I'm giving -y to avoid the prompt. This will clear all the leftover dependencies. Let's try that again. Let me clear the screen. Let's go to the top again. We don't see Ansible here. So that apt remove uninstalls the package, and apt auto remove clears the leftover dependencies. And there is another command like apt clean that removes any cached installation files. Let's try that too. Sudo apt clean. Let's check which Ansible. So now when we run which Ansible, it's gone. Means it's fully removed from the system. So let's quickly recap. So today we explored the Linux folder structure, what the /etc /usr/bin and /usr/lib and /var/log, what all these directories do, and then we installed Ansible to see how those folders are actually used by Linux during installation, and we learned what sudo and apt do. We verified where Ansible was installed and then removed it cleanly. This structure and flow apply to almost every Linux distribution, whether it's Ubuntu, Amazon Linux or CentOS. So these are the Linux folder paths. That's it for today's demo. In the next video, we will dive deeper into Linux file permissions and shebang lines to see how Linux decides which interpreter runs a script. If you found this video helpful, please like and subscribe to the channel. Share it to benefit more people and add your comments or questions in the comments section below. Please note, captions are auto-generated but mostly accurate. Thanks again for watching. See you in the next one.